Okay, hello students. In this video, I want to clarify how to graph function gx equals f of minus x minus h. So, if f of x is original function, so how do we do that? We can use this. It, it, it could now. What are the functions gx you can think of is we have. It could be a constant function, or let's see if it is a x square function or cubic function, or it could be also a square root function, and it could be also cube root function. Not only that, it could be also an absolute value function, or it could be reciprocal function. It could be also exponential function, or it could be a logarithmic function, or it could be also transcendental functions, any sine trig function, any trig function, sine, cos, cosec, cot, tangent, or it could be also hyperbolic function, or sine hyperbolic of x, and could be cosine hyperbolic of x, and so on. So the question is, how do we transpose function of this form? So if there is if it is just a x, I'm going to take an easy example. Let's see if I'm working on x cube. So we know the graph of f of x is x cube. And how does the graph look like? Is this is the graph of x cube, right? So now the easy part is if we were asked hx, let's see, there was a question, what is h of x is f of x minus 3. What does it mean is, that means the original graph, this graph, the green graph, shifts. So this means, and remember this, there's a 1 here, right? So it's x minus 3. So the x is replaced. The input right now is x minus 3. So that means the graph, the original graph shifts to the graph, the new graph. So the graph of hx is, it is the graph of f of x, but it is obtained by shifting the function, the original function, 3 units to the right, 1, 2, and 3. So this will be 3, and this graph now, this graph, the original graph of cube, will go something like this thing. So that's the understanding of minus 3. That means the graph is shifting 3 units to the right. But I can write another one, px graph, which is f of x plus 2. And what does that mean is it is same as writing f of x of minus 2, where the h, right now the h is negative, right? So h is negative 2, it means shift 2 places to the left, and that's how we graph. But what about, before I show the other one, what about if the graph is, Rx is square x cube, let's see, I want to graph Rx as f of minus x. So what does this mean? It means the graph x is replaced by minus x. So this is reflection over the y-axis. That means you are replacing x by minus x. It means if this is the graph, so if this is the graph, then the reflection over the y-axis will be this one, correct? So this is how it works. That's what that means. Now the question is, let me go directly, is what is this means? To understand this, I'll take an example. Let's write down g of x is f of minus of x, and let's say it is minus 3. So how do we graph this? So students, this is the original graph of f of x, and we want to know what is f of minus x minus 3. It looks like, because I said if it is minus x, the first thing is minus x. The first part is minus x, and then that means you reflect over the y-axis. Okay, so this means this part is reflect over the y-axis, and the second part is it looks like the h here is 3 if you comparing here. Yeah, here. So h is 3, it means you shift 3 units to the right. So that's how there's a misunderstanding here. So do you shift to the right or do you shift to the left? So be careful here. All you do is, I want you to write this the inside the parenthesis as it is f of minus parenthesis, and put a box here. So this will be x plus 3. So what this basically means is the gx, the new graph, the first step is this minus is you first reflect over so this green color gets reflected over the y-axis because of this minus. So this x, so you first reflect over the y-axis, and then this plus 3, what does this plus 3 basically mean? It's f of minus of x, and I'm going to write this minus 3, and then that means this is that h. It means you are shifting 3 units, shifts 3 units left. Means if this is the graph, now the graph will be here. This graph will be this one, and this is -1, that's -2, that's -3. So shift 3 units to the left, and not like this one is like we think that you shift 3 units to the right. No, you shift 3 units to the left. So that's what I want to clarify in this video, that be careful of such cases, and the reason is, remember that this minus is what is important. So the first part is the x. So the first part of this function is you do g of minus x, and the second part is like the minus stays, but the input, this input is replaced. This input is replaced by that x plus 3. See? So it is the x is replaced by x plus 3. So that's the important thing, and that tells you that you have to move shift to the left. Hope this helps. And it can be any graph also. Let me see if I try to think of square root graph actually. And let me take one more example there. So let me write f of x is square root of x, right? So what does new graph hx, if I write it is f of minus x n plus 4x. What does this basically mean? Okay, step 1. Don't make a mistake. You can't reflect over the x-axis, and this means it's a plus 4, do the opposite, moving to the left 4 units. No, this basically means it is f of minus of x minus 4. In other words, first hx, the original function. So this part, the square function. The square root function is this. This is the square root function. This square root function, first you reflect over the y-axis. So you first reflect over. So this is what you get. First reflect over the y-axis, and then now remember the new function is square root of x. So this is, we want to know what is this, right? That's our goal. What is that? And you can see first you reflect over the y-axis, and then there's a minus 4. This is the h, which is plus 4. That means you shift 4 units right. Shift 4 units right. So that means this thing goes 1, 2, 3, and 4. And this graph, the new one will be something like this. So, and the question is, how do we know this is really true? And you can see this the inside, the radicand that you see is negative x plus 4, and this negative is the domain. You can't have a negative in the square root sign, so this has to be either positive or 0. So, and you solve for x, subtracting 4, you get minus x greater than minus 4, and if you divide, and you divide by minus 1, because when you divide by minus 1, the sign changes and you get x less than equal to plus 4. And clearly see, this is plus 4. So the domain, for this is everything, including this the 4 and then everything to the left. I hope this helps. And it can work anywhere like this. Okay? I hope I did wanted to really put, and then another way is there another way to do this? Let's see, if this was the case, another way to do this also is the original function that you have. Let's see, this is the original function, and if this is the square root function, you can also think it like you put it this way. See, it's like you shift. So this basically means shift 4 units to the right. So you can do another way. First of all, you move 1, 2, 3, and 4. You shift this to the right. Okay, and then you reflect not over the y-axis, but you reflect over this point. That means this point will be. That means this whole thing is reflected over the line x equals 4. So this is like x equals 4. So this dotted line, let's say, is x equals 4. So that means gets reflected. It was this one, right? And then, so there are two different ways. One is you first reflect over the y-axis and then shift 4 units to the right, or you can shift 4 units to the right and then reflect over the line x equals 4, not the y-axis. Be careful there. And you can see the domain we have seen, it has to be less than or equal to 4, so it reflects over the. Hope this video helps. Okay, thank you so much. I just wanted to clarify anything.